Hi everyone. So I have something a little different today. I have here a Vizio TV model M552i-B2, where I was told that the TV would no longer power on and there was a smell of burning. And so I thought I would take a crack at seeing if we can fix this thing. So normally when some sort of consumer electronics fails, without a schematic to go on, without any information from the manufacturer, it can be sometimes very difficult to track down what the actual failure point was. But I thought since there was a smell of smoke and the TV wouldn't power on anymore, that sounds like something in the power board failed. And if it's burning enough to make smoke, hopefully we can find it by visual inspection. So let's take a look inside and see what we can come up with. So here's the inside of the TV with the back cover removed. There's a bunch of screws that had to come out of the way in order to get that off. And this one here is the power board. And so I was looking at all the little components here, trying to figure out if anything looks blown, trying to shine a flashlight under these heat sinks to see if any of those MOSFETs or whatever they are under there look like they burned up. Flipping it over to the back side, looking at all those little surface mount components to see if any of those look blown up. And I was having a really hard time finding anything that looked damaged until I read online that this chip, which is labeled on the circuit board as IC901, that chip has a tendency to be failed. And sure enough, if you look at that leg right there, the second leg from the right, there's some melted plastic on there. So I think that that chip started to burn up and the TV was unplugged before the chip completely blew out. But I think that is where the smell of smoke came from. And that chip is labeled LD7913JGM6. But now, integrated circuit chips don't normally just blow on their own, so I think probably one of the other components around it failed first, and that caused an overload in this chip. So we need to figure out which of these other components around it failed first. And for that, to do any testing, those components will need to be removed from the circuit. So I was hoping we were just going to find a blown capacitor and I'd be able to get a very generic part in order to replace it. And it didn't quite work out that simply because we have a very specific chip that I'm going to have to replace. But with a little luck, maybe we can do this pretty inexpensively. So I'm going to have to get some of these components desoldered and see if I can figure out which components failed. And this power board is model DPS-167DP-1A. And so in addition to that integrated circuit IC901, which you can see in this light is burnt, is melted near that pin, the internet suggests that this is actually fairly common, and the common failure modes involve this diode, a Schottky diode D950B, this resistor R915, and that Zener diode Z909. So I'm going to get those three components desoldered and see how they're doing. Alright, so fingers crossed, I think I managed to desolder one end of each of those three components without damaging anything else, I hope. And so let's see what we've got here. So I'm not sure what this resistor is supposed to be, but I'm measuring it as an open circuit, and that can't be right. So I'll have to track down the markings on that. This is the Schottky diode. Which is dead short. And the Zener diode, yeah, you're shorted also. So I think all three of those components are bad. I wonder if maybe one of them failed and took out the rest. Yeah, both of my diodes are shorted and my resistor. And I guess just fingers crossed that those really are the components that failed and nothing else, because there's all sorts of other components in here. Hopefully these are just more Zener diodes of the same rating. From posts online, it sounds like the Zener is a 4.7 volt Zener, and this is a 2 amp Schottky diode that some people like to replace with a 3 amp Schottky diode. And I need to track down the markings on this resistor to figure out what the resistance was supposed to be. So with the integrated circuit, that's 4 components that I need to replace. And all 4 of them are clearly bad. And I'm really just, without a schematic or anything, I'm really just putting my faith in the other people on the internet who have solved this problem before, in hoping that nothing else is broken. Okay, so I will try to procure replacement parts, and we'll reconvene when they arrive. And of course, there's an argument to be made that I should just replace the entire board. And replacing the entire board would save me from crossing my fingers and hoping that nothing else is broken. But of course it costs significantly more to replace the entire board, and I would just be getting a used board out of another TV that might be about to fail too, because it sounds like this is a really common failure mode. And I don't know if maybe the Schottky diode is the thing that fails and brings everything down with it, because people are replacing it with higher rated diodes. But I don't know. I'm not going to try to reverse engineer a schematic of this thing. There's too much going on. And I'm not really an electronics repair expert. I'm just trying it because I was hoping this would be an easy fix, and it's working out to not be as easy a fix as I was hoping, but I think we're still within the realm where this is fixable. So fingers crossed. And in doing my legwork on this, I found that this must actually be an extremely common failure mode, because there are, I think, 3 different threads on badcaps.net that talk about it, and you can even buy a repair kit on eBay where they'll ship you these 4 components to you for about $20 to $25 here in the US. They're very secretive about exactly what they're sending you. I guess you're paying for their expertise and sending you the right parts, although like I said, this repair at least is common enough that you can find that information online. And I'll put that information in the description below so you don't have to dig around as much as I did for it. Once you know which parts you need to replace, the only thing that might be a bit of a curveball is this resistor here. Now that I've got one end of it unsoldered, you can see that it's got some markings on there that I think signify that it's a fusible resistor. So the fact that it failed open was no accident. It's supposed to do that when it gets overloaded. And like I said, I'm not going to try to reverse engineer the circuit diagram here, but if I were to hazard a guess, I would say that probably the Schottky diode shorted out, perhaps due to heat, and that led to it drawing too much current and overloading both the integrated circuit and the Zener diode over here, burning them up before that resistor, fusible resistor, fused in order to prevent fire. So I'm hoping those repair kits on eBay would send you a fusible resistor and not just an ordinary one, because the manufacturer would have done that as a safety precaution. I thought I'd do a little investigative journalism and ask those sellers if the replacement resistor they ship is fusible, but I didn't actually get an answer to my question. One of the sellers didn't respond to my inquiry, and the other told me that I'd have to buy the kit to find out what was in it. Which I find a little questionable on 2 levels. Like I said, I understand that they want you to pay for their expertise in picking the parts, but I wasn't asking for any detailed specs to be able to order the part myself. I was really only indirectly asking yes or no if their repair kit would turn this board into a greater fire hazard than it was with the original factory components, which I feel like a consumer should be allowed to know before they decide to buy the kit. Because you can put an ordinary resistor in here, and as long as we don't have the same failure occur again, I don't think it would make any difference. And then the other thing is, I don't think you can actually tell by looking at a resistor whether it's fusible or not. The original one was clearly funny looking and specially labeled, but from what I can see, I think the kits ship you something similar to what I purchased, which just looks like an ordinary resistor, and I have to kind of take it on faith that the seller is telling me the truth when they claim it's fusible. So even if I bought one of their kits, I don't think I would ever really have an answer to the question. But even then, honestly, and I don't have any data here, but I think most ordinary resistors, whether they're advertised as fusible or not, probably tend to fail open in an overload, or at least to increase in resistance if they don't fully open. So maybe one could argue that it's really not that big a deal, but if I, as the customer, am worried about safety and I get the brush off, then that doesn't really make me want to do business with you. So I feel like you have to weigh that when deciding how secretive to be about your kit contents. And to be fair, they do make a big deal out of having an upgraded version of the Schottky diode, which I assume means they're providing a 3 amp rated version, unlike the original 2 amp. I did the same, and you'd like to think that that might prevent this sort of failure from ever happening again. But for my part, I'm not going to defeat any safety measures if I can readily avoid it. So I made a point of ordering resistors that were specifically advertised as fusible. I'm guessing from the markings that the original resistor was rated for half a watt, that 1/2J refers to half a watt, but I got the 2 watt version in addition just in case that guess is wrong. I think the original component was made by a company called Futaba, but I couldn't find any data sheets that seemed to quite match up with the markings on this component. So that's the one thing that I am slightly guessing about, but I'll start with the lower rating, the half watt, and if that doesn't burn up, then we should be good to go. Anyway, this TV is around 10 years old. From eBay data, it looks like in November and December of last year, 2023, there were 8 repair kits sold, 3 repair services where you mail in the board and they repair it for you were sold, and 7 complete replacement boards. And I couldn't tell you how many of those people actually succeeded in repairing their TV, but it certainly appears that I'm far from the only person trying this. So with that, let's get on to actually trying it. And so for the most part, the components came off without too much of a fight. On the back side of the board, you have to be careful not to burn all the tiny little surface mount parts. This is where the integrated circuit was. So it's got lots of tiny little surface mount parts that hopefully I didn't burn in the process. And then the diode is proving to be a little bit of a production, the big diode, in that it had these metal standoffs that were holding up the old diode. But because I upgraded to a 3 amp diode, the leads are a lot thicker, so I couldn't ram them through the standoffs. And so I've been having to remove the standoffs that I assume are there to make sure that the diode is elevated enough from the board that it can dissipate heat a little better. So what I had to do there was to kind of remove the solder from the backside as best I could using a soldering pump and a solder wick. And then from the top, I got the legs hot with the soldering iron while using my other hand with diagonal cutters to kind of rock it and twist it around, trying to bend all those little tabs and get them free. And that seems to be working, but it is a bit of a production, and you can see I'm making some scorch marks on this board. So hopefully I'm not damaging anything. I don't think I've obviously damaged anything yet, but yeah, this is a little bit of a production. And that integrated circuit takes the prize for the most difficult part to solder. You can see some more of my scorch marks there. And on the back is really where things were kind of tricky with all those little surface mount parts around them. I don't think I burned anything. I don't think I shorted anything. I had to break out my 35-cent tin of soldering paste. The flux that's just built into my solder wasn't enough, so hopefully soldered paste doesn't expire. I think this might be a little bit old, but I think I got it in, and I'm not gonna quit my day job to go into television repair, but I think this just might work. All right, fingers crossed, let's get this reinstalled. I already cleaned it up as best I could with some rubbing alcohol. So let's see if this works. All right, and now the moment of truth. I've got the board reinstalled, and it is plugged into a GFCI outlet just in case anything goes horribly wrong. Safety first, guys. Let's see if this works. All right, so that clearly did not work. So what I've done next is to desolder one end of the diode 801, D801, because someone in one of the posts on badcaps.net had suggested that theirs seemed to be bad, although it's not clear exactly how they were testing that, but mine works out fine. It's got about half a volt voltage drop across it. I also decided to check D902B right here simply because trying to test it in circuit, it seemed like it might have been shorted, but once I lifted up one leg, I was able to confirm that that diode is also working just fine. So as I continue troubleshooting this, I'm looking more and more at the data sheet for this IC901 chip, the LD7913J. And I do get, when I plug this in, about 170 volts on the drain pins here, but VCC, that separate pin off to the left, is not getting any voltage. It's at ground, 0 volts. So for some reason, this chip is not charging up this capacitor's C904B. So I desoldered C904B and it is still good. It's still got its rated capacitance. So my next guess is that PC902, which is an optocoupler that I've removed here, might be bad. I don't know if I can come up with a way to test it or if I'm just going to have to replace it and see if a new one works better. But from tracking what's going on the underside of this, tracing out where all these different traces seem to go, that middle optocoupler seems to be the one that ties in to the feedback on the comp pin, which is pin 4, if I'm not mistaken. So I will see what I can do with that. And I also want to note, while I've got this here, that where I was going to all that effort to replace D950B and dealing with those standoffs, if I removed the old D950B, I'm fairly certain I could have just put the new one in D950A and not had to get rid of those standoffs that were in the way, because again, if you look at it from the underside, they seem to be on exactly the same traces. So anyway, fingers crossed that this optocoupler might be it. If not, I'll have to look at the brownout. So the optocoupler is used in feedback on the compensation pin. If that's not it, I'll have to check out the brownout protection, which is another feature of this chip, that if the brownout pin voltage drops too low, it turns itself off. That's another reason it might not be charging this capacitor. So the hunt continues. Okay, so to test a photocoupler, I've got my Fluke multimeter here set to resistance mode, measuring the resistance across the transistor side, and it's over the limit. It's basically an open circuit. And then I've got another meter here that I'm setting to diode test mode and doing it across here. And you can see that with, something like 1.1 with 1 volt across the diode, I am getting down into the kiloohm range. So it looks like my optocoupler is still working. The hunt continues. All right, so that optocoupler in the feedback loop was fine. There was nothing wrong with that, so I've reinstalled it. And so I've been staring at the underside of that integrated circuit that we replaced, IC901. And there is a brownout protection pin, this second one from the top, that turns the chip off if it's not above roughly 1 volt. There's some hysteresis there. So I've noticed that that pin is connected by a roughly 130K resistor to ground and by a roughly 130K resistor to the VCC pin, which is not charging. It's at 0 volts when it's supposed to be charged to, I think, I think at least 11 volts according to the data sheet, and that's not happening. So for some reason or another, this is not charging. And so trying to trace this all through, some way or another, capacitor C904 here needs to get charged to at least a couple volts before this chip will turn on and finish the job. And following that, this end of it goes through to pin 4 here on transformer T901. And this end, if we follow that path, so this end goes through a resistor, through a junction on the other side of the board to here with a diode and another diode through some resistors that are fine, and these diodes are fine. This is one of the diodes we replaced, to pin 1. So I believe pin 1 is responsible for charging that capacitor that's not getting charged over here, that is necessary to turn on this chip. So I desoldered this end of that transformer. And I'm having trouble finding a data sheet for this transformer, but from another post on the internet, it sounds like these two inner pins, numbers 2 and 3, are the primary, and numbers 1 and 4 have something to do with that VCC. So I feel like there should be an AC voltage on 2 and 3, and there is not. So I'm really at a bit of a loss here. About the only thing I can think to do is to wave around some hot air and hope that reflowing something will fix whatever's going wrong in here. So it's kind of a desperate attempt to do something, but I don't know what else to do. So let's see what happens. And that's that, I guess, even after using that soldering hot air station to try to reflow things, it still doesn't want to turn on. So that outcome is a little disappointing, but I don't know what else I can do here, short of replacing the entire power supply board, of course, which I do think would fix it, but that's at least a $50 board, so I'll have to decide how much I really want to get this TV back up and running. But anyway, I hope you found this entertaining, and if you enjoyed it, please give this video a thumbs up. Thanks.